Hi, welcome to Lesson 17, Session 2. Today we'll be working on dividing a decimal by a whole number. We learned a little bit about the idea of dividing with decimals yesterday, and remember that last week we learned all about multiplying with decimals. So today we're going to be starting with a decimal and then dividing that decimal up into equal parts. So we are going to be working in our Ready Classroom Math Workbook on pages 351 through 356. So go ahead and turn in your Ready Classroom Math Workbook to page 351. And I happen to already be here. So this problem says this. Coach Ann is setting up a 2 7/10 kilometer race. She uses flags to mark off 9 equal sections of the race. How far apart should she space the flags to mark off the sections? So first of all, what is this question? What is this question talking about? What is it talking about? And it's talking about flags that are in equal sections of the race. So we have a race and we want to put up these flags along the route of the race. Now, what is it that we need to find out? What is it that we don't know? What we need to find out, what it is that we don't know, is how far apart should she space the flags to mark off the sections? And what we do know is that the whole race is 2 7/10 kilometers long, and we know that she wants to make 9 equal sections. Now, when you guys look at the information, we have the 9 and the 2 7/10, you might very quickly see maybe a math fact that you might know in your brain. I want to show you kind of like how to work with that. So first of all, what is the problem that we're trying to solve? What it is we know that we have a race that is 2 7/10 long, and we're dividing that race into, sorry about that. We're dividing that race into 9 equal sections, and then the resulting answer is going to tell us how long each of those sections is. So that's what we don't know. Or we could also look at it this way, that we have a race that is 2 7/10 long, and we know that we have part of this is, we know that we need to break this into, let me see if I can make this look kind of right. There we go. So we know that we're going to break this 2 7/10 into 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. I'll even draw them all the way up like this. We're going to break this 2 7/10 into 9 equal parts, but we need to know what each of those parts is. We don't know right now. So here's one way to solve it. We can think of 2 7/10. How can we think of that just in tenths? How many tenths is 2 7/10? That's right. It is 27/10. So if we know that we have 27/10, we want to take those 27/10, because that's 2 7/10, those 27/10, and divide them into 9 equal parts. So what is 27 divided by 9? That might be a problem that you know how to do. But remember, this is not 27, this is 27/10. So our answer is going to be in tenths. So the math fact that we know, we might not know what 27 divided by 9 is, but what do we know that 9 times a number equals 27. And that's right, 9 times 3 equals 27. Now, 27/10 divided by 9 equals 3/10. So then our answer, how would we write 3/10 as a fraction? How would we write 3/10 as a decimal? So our answer is 3/10. Each of these lengths is 3/10 long. Now, if we aren't sure if that's true, we can always do math to double check. So if we had, I'll go ahead and use a different color. So if we had 3/10 and we multiplied it times 9, because we have 9 parts, our answer should be 2 7/10. Well, 9, remember, we ignore that decimal when we're multiplying decimals. 9 times 3 is 27. And then 9 times 0 is 0, so you don't need to worry about that. And then how many digits do we have after the decimal? We have 1. So our answer or our product needs to have 1 digit after the decimal. So our decimal gets placed there. So yep, we are correct. 3/10 times 9 equals 2 7/10. Now, the easiest way to remember to do this is to think of it as to change the decimal into tenths or hundredths if we were working with that. Then do the math fact that you know, and then convert it back to a decimal. That, in my opinion, is probably the easiest way to do it. But we are going to look at a couple of different ways. So go ahead and turn the page to page 352. So on here, they drew a very similar picture to what I just did. It says you can draw a bar model to represent the problem. You know the number of kilometers to be divided, which is 2 7/10 kilometers, and we know it's being divided into equal groups. And we also know the number of equal groups. We knew that there were 9 groups. So we took this bar, we broke the bar into 9 equal groups. We know that the whole length is 2 7/10. So we need to see what is 2 7/10 divided by 9, and we know that each of these parts is equal to 3/10. Now it says we don't know what it is, but we do because we did just solve it. You can also use the relationship between multiplication and division to understand the problem. So to solve 2 7/10 divided by 9, you can also think about 9 times what equals 2 7/10. Then, if you use the place value understanding to find the missing factor. When this is kind of what we did on the last page. 2 7/10 is equal to 27/10. 9 times how many tenths equals 27/10. We know that 9 times 3/10 equals 27/10. So 3/10 we can rewrite as 3/10. All right, let's go to the next page. And so we're going to do a little bit of talking about what we just did on that last page. So it says, why is the bar divided into 9 equal parts? So on this picture it over here, why is this divided into 9 equal parts? Well, that's actually pretty easy. Well, the question says Coach Ann marked off 9 equal sections. Therefore, since there were 9 equal sections, that means that there were 9 equal parts. So that's why we broke this into 9 parts, because there are 9 groups. Now, what is it that we need to find? We know the total distance. We know how many groups they are. What do we need to find? We need to find how long or how big is each group, or what is, we need to find the length of each section between flags. So remember, we're going to put a flag up at the end of every one of these groups. These are all of our flags, including a flag at the end of the race. So when we count up all of our flags, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 flags. So that tells us that we have 9 groups. And then what we don't know is this right here. This, how long is K? In fact, I'm going to put a little parentheses K, because that's telling us how long is this section here. Now, if we're looking at model it down below, how does the division expression 2 7/10 divided by 9 relate to this bar graph up here? 2 7/10 divided by 9. So for us to find the length of each section, remember that's K, to find the length of each section, you need to divide 2 7/10 by the number of groups. So that's what this 2 7/10 divided by 9 is shown on the bar graph. Number 3 says, explain how you know that 2 7/10 is equal to 27/10. So how do we know that? Well, we know that this, if we're looking at just the 2 wholes is equal to 20/10. Because 1 whole would be 10/10, so 2 whole would be 20/10. And then if we look at the second part of that 7/10, we can say 7/10 is equal to 7/10. And then when I take 20 and I add 7, that equals 27/10. So that is how I get my 27/10. Now, some of you may not need to look at it that way. Some of you may say, well, I recognize that this 7 is in the 10th place, so I'm going to turn this into tenths. And I know that if I think about this number as a whole, 27/10, you're saying the number that you see minus the decimal, and then the place value tells you the word that you use at the end, the place value of the smallest place value. Now, based off of what we've done in the last 2 pages, how far apart should Coach Ann space the flags? Well, we recognize, or we see, that she should space the flags every 3/10. So the answer is 3/10 of a kilometer. Write the distance of 3/10 as a decimal. Well, that would be written as 0 and 3/10. Using the word and for your decimal. Now explain how you could divide a decimal by a whole number. So this is a little wordy, but I think that you'll be okay. I want you to go ahead and make sure you pause this video and write this all down, and then unpause it and then listen to me talk about it. All right, you can use the related multiplication equation, kind of like inverse operations, and find the missing factor by thinking of the number in its place value. So again, 2 7/10 divided by 9 is the same as 9 times what number equals 2 7/10. Then you can divide the whole numbers and then place the decimal point to show the place value. So again, we took the division problem. We thought about it as a multiplication problem. Then we changed our decimal into a whole number. But remember, we need to make sure we leave the word tenths there at the end so we know that we're still talking about tenths. You find your answer, which in our case was what is 9 times what equals 27, and that would be 3. And then but remember it's 3/10, and so then you place your decimal back to show that it is a tenth. Now, we're going to look at number 6. Remember, it's always our reflect about the strategy that we like best. So today, we learned 2 different strategies. The first strategy we used to divide a decimal by a whole number, is to draw a bar model to represent the problem. We also use the relationship between multiplication and division to understand the problem. So would you rather, or which do you prefer, using a bar model or using multiplication to divide? Either of those methods will work, and they both are quite effective, actually. All right, go ahead and go to the next page. We're going to look at number 7. So number 7 says this: how much will each person receive if $20.35 is split equally among 5 people? Show your work. Now, this problem, I'm going to actually kind of break it apart. So I'm going to think of $20.35. I'm going to write that out in a little bit of expanded form. I'm going to break it apart into $20 plus 35 cents. And the reason I'm doing this is because I can see that I have this much money and I'm breaking it up by 5 people. And so now I'm going to look at this $20. If I have $20 and I want to divide $20 into 5 groups, what is 20 divided by 5? Do you guys know? So let me rewrite that. So I want to go 20 divided by 5 equals. If you don't know, remember you can think of this as a multiplication sentence. What number times 5 equals 20? That's right, 4. So we know that 20 divided by 5 equals 4. So we know that each person is at least going to have $4 because we've broken apart this 20 into 5 parts, which is $4. Now we need to break apart this 35 cents into $5. So if I had 35 cents or 35 hundredths and I divided that by 5, what would be my answer or what would be my quotient? Now, some of you may know the related multiplication problem, but let's think of this as 35 cents is the same as 35 hundredths. So what is 35? So then what is 35 hundredths divided by 5? Well, I know that 35 divided by 5 equals 7. And because 7 times 5 is 35. And then remember, I need to keep the same word there. So I need to keep hundredths. How do I show 7 hundredths as a decimal? That's right. I know since it's a hundredth, it's going to have 2 digits that come after the decimal. And so I've got 2 digits. Now, if I put that 7 right next to the decimal, would that mean 7 hundredths? No, that would mean 7 tenths. So now I'm going to add the 7 hundredths to the end of my answer. So now I've done $20.35. While I don't know what $20.35 divided by 5 is easily, I can break apart the 20 and the 35 cents and find out how many times 5 goes into 20 and how many times 5 goes into 35 hundredths. And then take the 2 resulting the quotients and put them together. So each person gets $4.07 or 4 7 hundredths. That one's a little tricky, but I'm hoping that as we go through and do these examples that they'll make more sense to you. Now let's look at number 8. It says, what is 99 hundredths divided by 11? So this one is a little bit easier. So we have 99 hundredths divided by 11. So first, let's go ahead and turn that into a multiplication sentence. What number times 11 equals 99 hundredths? Well, let's turn this 99, let's turn this 99 hundredths into a whole number. So 99 hundredths is equal to 99 hundredths. Now, what number times 11 equals 99? Or I'm going to leave that hundredths there so we don't forget. Well, I know that 9 times 11 equals 99. So, but it's not going to be 9. It's going to be how many hundredths times 11 equals 99. So it would be 9 hundredths times 11 equals 99 hundredths. Like I said, a little bit tricky, but I think that you guys are going to get it. So then if we wrote this as a decimal, the answer would be 9 hundredths. Finally, what is 51 and 2/10 divided by 4? For this one, I'm actually going to go ahead and use a multiples of 10. I think that that's going to be the best way to kind of help you. So bear with me. So let's go ahead and first start with the problem. So we have 51 and 2/10 divided by 4. Now, I want to think of this whole number in tenths. So how would I think about 51 and 2, actually, I don't know if I want to do it that way. No, I do. All right, so if I think about 51 and 2/10, how do I think of that in tenths? So it would be, what is 500, 51 and 2/10 is equal to 512 tenths, because we're looking at this whole number. And now we're going to divide this 512 tenths by 4. So to do that, we're actually going to go ahead and do partial quotient method. So we're going to find out how many groups of 4 can go into 512. So I know it's been forever since you've seen one of these, but let's go ahead and see if we can figure this out. So how many, remember, the first step we do when we're doing partial quotient method is we figured out how many groups of 10 can 4 go into 512. So, and hopefully you'll remember how to do these. So if you have 4 times 10 is 40. 4 times 20 is 80. 4 times 30 is 120. 4 times 40 is 160. 4 times 50 is 200. Remember, we go until we can't go any higher or until we hit 100. 4 times 60 is 240. 4 times 70 is 280. 4 times 80 is 320. 4 times 90 is 360. 4 times 100 is 400. So we're going to use that 400 as our first partial quotient. So 4 times 100 equals 400. So 100 is our first partial quotient. And then we're going to go ahead and subtract. 512 minus 400 is 112. Now, we're going to go back to our multiples of 10 chart. Hopefully you didn't erase it. We're going to see how we still have 112. How many multiples of 10 can 4 go into 112 without going over? Okay, well, if I get to 120, I went too high. So I want to look here. So it's 20. So 20 is our next partial quotient. So I'm going to go ahead and write 20 up here. 20 times 4 is 80. That is 4 times 20. And then I'm going to subtract. 2 minus 0 is 2. And then 11 minus 8 is 3. And then 4 goes into 32 8 times. So now I have all of my partial quotients. So I'm going to add 100 plus 20 plus 8. And all together, that equals 128. But we're not done yet. The answer is not 128. Now we need to look back at our original 512. Remember, this 512 is tenths. So how do I make my resulting answer into a tenth? How many digits come after the decimal in my original factor? That's right. One number comes after the decimal. So I'm going to put my decimal point back in and get that my answer is 12 and 8/10. I know that today was a lot. I have faith that you guys are going to get this. We are going to go ahead and do pages 355 and 356 on your own, checking in with your teacher. If you have any problems, I know that you're going to be able to get it. I just can feel it. And then you're probably also going to be doing some fluency practice. So between all of that practice, I think that by the end of today, you're going to feel really solid in dividing a decimal by a whole number. As always, you can always email your teacher. Otherwise, I will see you next time.